The second part of 6.4 will have us translating the sine and cosine functions either up and down or left and right, along with the possible stretching and compressing. You'll know that you have translations vertically and horizontally if anything's being added or subtracted either with x or on the outside of the trig function. We're now going to introduce two new parts to our equation. We're keeping the a and the b for the coefficient out in front and the possible number being multiplied to x, but we're now going to possibly have something added after, which is the d value, or added with x itself, which is the c value. All of these things will change the shape of the graph. We know amplitude. Amplitude is found by our a value, and that's the same as 6.4 day 1. Really no changes with that. The period of a function, we know that's our b value, and that will change the horizontal either stretching or compressing. Now if there's a vertical translation, this is actually going to be the letter d in the equation. Notice d isn't in parentheses, so it has to be written completely outside of the trig function, not in parentheses with x. And if anything's being added or subtracted, what that will do is it will move the graph either up or down. So you'll take your output values and either add that number or subtract it, depending on what it is. Now the horizontal translation is a little bit trickier to calculate. If something's being added or subtracted to the inside with x, so it has to be in parentheses, that value will move the graph either left or right, and you have to take whatever the c constant is, that number, and divide it by b. That's how far left or right you move it, and it's going to go in the opposite direction. What I mean by that is if c is negative in the parenthesis, if it's subtraction, you're actually going to move the graph to the right. If it's addition in the parenthesis, you're going to move the graph to the left. So that'll be a little bit different to kind of determine other than that d value. Let's see how this actually affects our outputs and our inputs. The adjustment to your outputs, we're still going to model the a times y rule that we did in day 1. You're also going to either add or subtract d the same sign. When we have a positive or negative, we're just going to say positive or negative in our new table. For the inputs, we have to find a new start and a new end point. When you have that change in c, if there's a c value being added or subtracted to the inside, we actually move the start value right or left. To figure out the new start when there's a c value, we set the parenthesis equal to the original start of 0, and then we have to work backwards to solve for x. To find the new end point when there's a c value, we set the parenthesis equal to where the original ending was for one cycle of the wave, and then we have to solve for x again. And then we'll use our graph if we need to determine those points in the middle. We'll try to keep any changes with that c value as straightforward as possible on our equations. All right, let's take a look at our first translation. We have y equals 3 times sine x plus 2. What we want to do is describe the translation like we did in 6.4 day 1. We'll graph our parent function, and then we'll graph the translation. Let's take a look at the values that we have. The number out in front of sine x is 3. That's our a value. It's in front of the trig term. If a equals 3, we know that our amplitude is 3. It's just the absolute value. That means our graph is going to stretch vertically. So that's just like what we did in day 1. Notice there's not technically a number in front of x. That means b equals just plain 1. And if b is 1, it's just like the parent function. There's no change for the horizontal stretch or compress. So that's nice. One less thing to have to try to worry about with our inputs. And the plus 2. The plus 2 isn't in parentheses with x, so that would be the d value. Since there's no parentheses, c is technically 0. So we're not moving the graph left or right either. It's just nice to kind of check in with all 4 of the variables or 4 of those possible numbers to see what's going to happen to the shape of the graph. Okay, now that plus 2 is the d value. D equals 2. That's an equal sign right there. If d equals 2, that means the entire graph is going to move up 2 units. So it'll be up just a little bit higher than the parent function. Those are all the kind of descriptors that we need. Let's go ahead and start by finding the parent function for sine x and sketching that graph. Whoops. All right. You guys go ahead and do that. We know this parent function. It's the same as what we did in day 1. So make your table, sketch your graph edge to edge, and then press play, and we'll do the translation together. All right, hopefully your graph looks something like this when you're done. Now let's take a look at our translation. We have y equals 3 sine x plus 2. With the a and the d value, what these two numbers are going to do is now just kind of create a new ay plus d for our table. The nice thing about the a and the d is they only affect the outputs. They don't affect our inputs. Therefore, all of our input values are going to stay the same as the parent function. So I'm just going to kind of draw this a little bit bigger for that second part. We have 0, pi over 2, pi, 3 pi over 2, and 2 pi. For the outputs, we're going to take 3, which is the a value, times all of our original outputs. And then we're going to add 2 to those. Here's what it looks like. For the first output of 0, 3 times 0 is 0, plus 2 gives us a new output of 2. The second output is positive 1. 3 times positive 1 is 3, plus 2 goes all the way up to 5. Back to 0, our graph will go back down to 2. When the output for y is negative 1, 3 times negative 1 is negative 3, plus 2 would be negative 1. And then if we're at 0, we go back to 2 for our translation. Let's plot these 5 ordered pairs and see if this gives us a curve that shows what we've described it to do. 0, 2 puts us up here on the y-axis. At pi over 2, we go all the way up to 5, all the way to the top of our graph. At pi, we go back to 2. At 3 pi over 2, we go down to negative 1. So we've got a match on our point, which is fine. And then at 2 pi, we go back up to 2. So if we just connect these 5 dots, go up and then bring it down, and then bring it back up again, that's one cycle or one period for the sine function. Now we said it was going to stretch vertically, and it looks like it's taller than the parent function. It looks like it stretches. And we bumped everything up 2 units. What we need to do now is just continue the pattern. So every time we go 1 to the right, we'll go up 3, and then 1 to the right, go back down to the middle, go 1 to the right, down 3, and then 1 to the right again, back up to that middle, that 2 value. We'll do the same thing in the opposite direction. If we go 1 to the left, keeping our pattern intact, we'll go down 3. 1 to the left again, we've got to go back up to that base of 2, kind of like that center for our function. 1 to the left again, all the way up to 5, and continue your pattern. Once you complete your dots from edge to edge, go ahead and sketch the rest of your translation curve. And hopefully your graph looks something like this when you've finished. All right, flip it over. Let's try one more. Graph y equals 1/2 times cosine pi over 4x in parentheses minus 3. All right, so now we have an a, b, and a d value. Let's see how that's going to affect the shape for our cosine function. We'll start with the value 1/2. If a is 1/2, that means the amplitude will stay the same, 1/2, because that's the absolute value. 1/2 is less than 1. Our graph is going to compress vertically. I'll just put vert there. Keep it simple. The b is pi over 4. So I'm going to put that over here on the right-hand side. I'm just going to slide this over here. If b is pi over 4, whoa, hang on. There we go. pi divided by 4 is actually less than 1. And if b has a value that's less than 1, how do we describe the function? It's going to stretch horizontally. Notice the graph I give you doesn't have the pi values on it, and b has pi in it. If you remember what we talked about in class on Friday, that means the period of the function is going to eliminate pi in the answer. To get the period of the function, we take 2 pi divided by b. Anytime b has pi in it, especially in fraction form, the pi's are going to cancel out when we multiply by the reciprocal. See that right there? And 2 times 4 is positive 8. So that means instead of stopping at 2 pi, or about 6.3, the graph is going to stretch all the way out to 8. So it will, in fact, stretch horizontally. All right, let's take a look at what's going on for the rest of the graph. That was the pi over 4 in the parenthesis with x, but nothing else is being added or subtracted. What that indicates for us is that c is 0. So there's no change shifting vertically or shifting horizontally left or right. Again, we're going to try to keep that translation with c as minimum as possible. We do have that d value. D is -3. And that means the graph will move down 3 units. All right, those are our descriptions. Because the period of the function cancels out pi, this is going to be one of those scenarios where we have to approximate our table. If you don't remember the numbers, feel free to look back to the cosine functions that we graphed in day 1, and let's sketch the approximate values for x and y on the cosine wave. Go ahead and do that. Put the graph at the right, press play, and then we'll look at finding the translation together. Hopefully your graph looks something like mine on the right. Let's go ahead and take a look at our translation. Remember, with the period of the function, we're now going to change the inputs, and with the a and the d, we're going to change the outputs too. We've got both things happening here. Y equals 1/2 times cosine pi over 4x minus 3. For our table, let's start with our inputs. If we want to start at the same location, we haven't shifted left or right, and we're going to end at 8. We need to figure out how to get those values in between. Well, halfway between 0 and 8 is 4. So that'll go right in the middle. Halfway between 0 and 4 would be 2. These should be nice and easy to plot for us. And then halfway between 4 and 8 would be 6. So those are all of your input values. For the output values, the y's, whatever a is, we're going to multiply that by y first. And then the d is -3, so we're going to subtract 3 from that answer. At 1, 1/2 times 1 is 1/2, minus 3 is -2.5, or -2.5. Hope I can get that to fit in there. There we go. When y is 0, up here, -1, or 1/2 times 0 just stays 0, minus 3 is -3. That'll be easy to plot. When y has an output of -1, 1/2 times -1 is -1/2. Minus 3 would be -3.5, or -3.5. Back to 0, that means our output 1/2 times 0 minus 3 goes back up to -3. And when y has an output of +1 over here at the end, 1/2 times 1 minus 3 is -2.5, or -2.5. Let's take a look at how that is going to affect the shape of our graph. I'm going to zoom this out to make it a little easier to plot my points. Notice I've labeled the kind of divisions on the bottom just to make the graph a little easier to see. I know we doubled them on our graphs for our homework, but that's because the graphs were significantly bigger. So let's just go 1 through 9 on the right and -1 through -5 on the left to make sure we've got enough space to fit our function in. All right, at 0, we're down to -2.5. So I'm going to put a dot. Whoa, whoa, hey, what's going on there? I thought I was going to put a dot. Yeah, here we go. Sorry about that. I didn't have the pen icon showing, and there it is. Now we're good. So 0, -2.5. And then we're going to go over 2 units And we're only going to drop down to -3. So we're not going to have a lot of kind of big arcs in these kind of curves for the cosine wave when we're done. At 4, we go down to 3.5, -3.5 right there. And then over to 6, we go back up to -3. And then at 8, we go up to -2.5. So it kind of looks like that little V shape, but we're going to make that curve as best we can. On the other side, we're going to go over to -2, back down to -3. -4 will drop down to -3.5. And now we have to try to make a curve to go through all these points. So let's see what we can do. If I start at the y-axis, I'll kind of curve down like so, and then catch that value for at 4, go back up, and then back down again. So not a lot of curve happening to that shape on the left-hand side. Same idea. I don't really like that part right there, so we'll try to make it look a little bit better. We'll see how this goes. Kind of curve that down like so. A little bit better, not much. So there's really not a whole lot of change happening there. We definitely compressed it vertically, we stretched it out horizontally, and we moved everything down 3 units. And I think that's enough. I think we're good. We'll finish the rest of the examples. There are 2 more of them. We'll finish them tomorrow or Thursday in class.